So we try to address the fundamental issue because you are in the fourth semester. So most of the students have answered electrical is something high voltage application and electronics is low voltage application, and others have tried in different ways. Now I will, and obviously most of you agree with it, then I will give an example. Have you heard of vacuum tubes? Right? Whether it was there in syllabus? No. No, but you have heard it. You can Google it or you can ask your parents about the radio sets which they were having at those days. Right? So, that vacuum tube, vacuum diode is there, vacuum triode for amplifier, tetrode, pentode, hexode, heptode, up to that they were there. So, what was the voltage range which was on which they were operating? Voltage range, and in anode it was also called as plate, cathode and plate, right? You can check that. So what was the voltage range at which the vacuum tubes were operating? Tentative range, voltage range? Anybody knows? It was around 100 volts. So vacuum tubes were operating around 150 to 200 volts operation. Do not, if you ask your parents who are not having any electronics background, what is transistor, what will they answer? If you ask your parents who do not, you look here. Looking here is a necessary condition for understanding, may not be sufficient, but sufficiency I can ensure, so I will ensure necessity. If you ask your parents what is transistor, who are not known exposed to electronics, so what will their answer? They know transistor in different context. What? A small pocket radio is called as transistor. Earlier, maybe 5 decades back, in 1970s, radio means was a big device and it required license, you may not be knowing. To hold radio, 15 rupees per year was to be paid, and postman used to collect that. It was a big radio set. Then, and it consisted of vacuum tubes. Then a small version of it, where amplifier consisted of transistors, has come. So, a pocket small radio, and that small radio was called as transistor. And that time radio and transistor are considered to be opposite terms of each other. म्हणजे कसं, जो व्हॉल्स आहे तो रेडिओ आणि जो ट्रान्झिस्टर वापरून केलेला आहे तो ट्रान्झिस्टर. Right? So when transistors, even though when were invented in 1948, to be popularized and come here, it took 20 years. So the transistor. So when transistors were not there, vacuum tubes were used in radio set. Right. One application. And second application, a mini torch. A mini torch, pencil, very small. A LED was not. LED you can also take, or no need for LED. Small bulb, a pocket, a mini torch was there, and those well-to-do persons used to carry. Those normal people used to have big torch, and well-to-do person were having a small torch, right? A mini torch, one battery cell, and one small bulb. So that is mini torch. So now, what is the operating range of mini torch? Operating voltage range? 1.5 volts, right? 1.5. Then by this classification, radio would be classified as which application? Radio will be Radio will fall under electrical engineering and mini torch will fall under electronics engineering. Is it correct? Yes. Radio is electrical engineering and mini torch is electronics engineering? No. I have deliberately chosen an extreme example to state very clearly that even, she is not wrong, even though prima facie most of the people feel that electrical is high voltage and electronics is low voltage, that is wrong. It has nothing to do. Very clearly, this is electronics. Even though it is this is electronics application and this is electrical application. So high voltage, low voltage is no longer a differentiating parameter. Then what? If not this, then what?
So in electrical engineering, we mainly study about creation and transmission of electrical signal, and in electronics we basically use it.
What is common in both things? First of all, common voltage, current, or charge, something related to charge. Actually, that is also a different scenario, sometime later we will discuss. But right now, flow of charge is in both of these things, flow of electric charge and what is flowing? Electrons, right? So flow of electrons is fundamental thing on which both branches are, what we can say, based upon. Now, what is the difference? What is electrical engineering application and what is electronics engineering application? Power again, not necessarily. Here also high power is there. Now listen very carefully. In electrical engineering, the flow of charge or electron flow is used. The purpose is transfer of energy. Electrical engineering branch involves all discussions, all things related to transfer of energy. And in electronics engineering, for what is used? Flow of electron is used for transfer of transfer of energy. The branch which deals with, means in both things, common thing is that it is the electrons which flow. Electron flow is fundamental. So electrical engineering deals with this flow for transfer of energy, and electronics engineering deals this flow for transfer of what? Transfer of energy is always associated, but that is, transfer of energy is not required. It is not the aim. Right. So you, how did you get this answer? So it's intuition. That is it is perfect. Very much. It is the thing which we were aiming at. So electrical engineering. So just like, suppose if I claim, it's not my claim. In general, this is a, what we can say, already known classical definition. But just like Edison and Swan, both invented incandescent lamp separately, near about same time, but the award was given to both. Why? They did not question who invented earlier. Why? While giving the award, the question was not raised who did first. Why? It was at a very near about time, and they were so remotely located that chance of somebody copying from other was not there. So even though something happened early and something happened next, the next happening is also given same weightage because it is independence. Like that, he should be also given same weightage of what we can say creating this definition, because he was not knowing it, right? So electrical energy is associated with transfer of energy, or power is also used alternatively, and electronics engineering is dealing with transfer of information. Everything related to information, that is signal, means changes in the signal, they can convey information, and that, so amplifier requires power. Amplifier, for its operation, it requires power, right? So energy transfer is not the issue at all. Plenty is available. Only thing is that how information is processed is important. So that is the main, very key thing. So from where we came here? Here, right? So this analog to digital converter converts it into a set of digital values. A set of digital values. So what is important is this voltage, how it changes, that is important, right? Because the transducer converts this signal into voltage, means voltage is just a medium of carrying information. And in electrical engineering, when you talk about, it is for transferring energy. This analog digital converter converts it into an array of some bit numbers. Now 32-bit ADC is very easily available. So it converts into a stream of 32-bit numbers. And at about 1 mega samples per second, 1 mega samples per second, what we can say, take samples and so in 1 second, 10 raised to 6, in 1 second, 10 raised to 6, he is looking at watch and he is presuming that the substantial part should be covered. Some, what we can say, huge time should be available. It's just like entering a mall. I think I have given that example. So, a stream of 32-bit numbers is generated and it is stored, because if it is only generates, it is likely that you can't process it immediately. So it is stored. So there are two parts. One is real-time processing and other is offline processing. So once transducer, there is actual signal, transducer converted into voltage, and that is ADC converted into digital samples, and those are stored. So this is digital signal, and then it can be processed online or offline. Once it is a stream of numbers, using computer you can do anything on those numbers. So those numbers are processed using computer. And after what it produces? It produces stream of another set of numbers. And that is given to DAC. And that is given to other transducer. Reverse, that is speaker. And again, actual signal converted to voltage, given to ADC, given to computer, processed, new signal generated, given to actual reverse transducer. So this is mic and this is speaker. What I talk here, that is again available here, and all kinds of things. You can process it. You can now let us say that Lata Mangeshkar is no more there, but now it is in, see, the next, from 2025 onwards, so the decade of 30s would be very heavily occupied by entertainment industry, because now the leave about pandemic now, the issues of normal livelihood are appropriately addressed, and once these issues are appropriately addressed, the question is, I have ample time, how to kill that time, and for that various entertainment things will come into picture, that there will be AI based poets, AI constructing poetry, AI constructing prose, म्हणजे कादंबरी, कविता हे AI मधून कॉम्प्युटर तयार करेल, and also you can design of vocal cord type like that using computer. Now, what is more superior, whether computer or human vocal cord? Again, there are debates. Means this is again a very interesting thing. We say that our ears are having that. Or that also I will take in the today. Today we will prepone the lunch break. At 12:15 we take lunch break, and at 1:15 we are meeting sharp. Now no more request for cancellation. At 1:15 we are meeting sharp. That time we will elaborate more. That something I can't listen beyond something that is said. But I can't listen means if you are put up with the sounds of beyond say 20 kilohertz, what will happen? You may not be able to understand something, but that may have some impact which is not immediately known to you. So we will come to all those issues in the next session.